Hello guys, you are welcome back from the break. Let's continue from where we stopped. Here we come to division of fractions, yet another subheading under fraction. Example 1. Divide 3 whole number 2 over 7 by 46 over 21. Something special about division. Division has its inverse to be multiplication. Now that multiplication is the inverse of division, whenever we are operating division, we are free to change it to its inverse. But anytime you change the operation to its inverse, the divisor also must change to its own inverse as well. When we say inverse, what do we mean? Inverse of A is 1 over A. Inverse of 2 over 3 is 3 over 2. Inverse of 7 over 9 is 9 over 7. You have the idea of what we call inverse now. So, this, which means 3 whole number 2 over 7 divided by 46 over 21. We can change this, the division operation, to its inverse. And its inverse is multiplication. And anytime we do that, the divisor will also turn to its inverse. What is the divisor here? The divisor is 46 over 21. What do we mean by divisor, by the way? Divisor is what we are using to divide something else, is what we call divisor. So here, divisor is 46 over 21. So let me change 3 whole number 2 over 7 to improper fraction. So 7 times 3 is 21, plus 2, 23 over 7. Now I change the division operation to its inverse, which is multiplication. So by doing that, the divisor 46 over 21 also will change to its own inverse. And don't forget the idea of inverse I introduced to you here. Inverse of 46 over 21 will be 21 over 46. Now, because I hate the idea of cutting works in a clumsy way, that when parents want to go through your note with you, the parent will not understand whether you are cancelling something or you are cutting. So I will introduce you to this neat way of cutting. Look at it. To make it neat, break every number here, the numerator, the denominator, to their factors. 23 is 23 times 1, 23 times 1, but I don't need the 1, so leave it as 23. 7 is 7 times 1, leave it as 7. But 21 is 3 times 7. Breaking it into its factor. 46 is 2 times 23. That's how to break this 46 to its factors. Apart from the universal factor 1, use every other factor to break them. Do you understand? Now, you can see here clearly that 7 here cut this. 23 here cut this 23. This cutting will not be clumsy for any parent to look at. So, what do you have left? You have 3 over 2. At the numerator level, you have 3. At the denominator level, you have 2. So you can leave your answer as 3 over 2 or 1 number 1 over 2 as a mixed fraction. Do you understand? Good. Example 2. Simplify 5 whole number 3 over 8 divided by 3 whole number 7 over 12. 8 times 5, that gives 40. 40 plus 3. That's 43 divided by 8 divided by 12 times 3. That's 36. 36 plus 7. That is 43 over 12. So, we now change the division sign to its inverse. 43 over 8 times, that is, I change the division operation to its inverse. The inverse of division is multiplication. For doing that, I must change this divisor also to its inverse. What is the inverse of 43 over 12? That will be 12 over 43. So, I break every number into its factor to have 43 over 2 times 2 times 2 times 12 will be 2 times 2 times 3 all over 43. Please, I want you to admire this method. It will make your work neat. Unlike someone who just cut, and the teacher cannot see whether you are cutting or you are cancelling your work. You just paint everything, which is not presentable. When you break every number into their factors, it will make it, neat. Look at it. You can see that this 43 will cut this 43. You can see that I don't break 43 further because 43 has no factor other than 1. So if I want to break 43, I will write 43 times 1 because 43 is a prime number. And don't forget, a prime number has only 2 factors. That number itself and 1. So the 43 itself and 1 are the factors available there. So that's why I write only 43. So 2 cut 2, another 2 cut 2. So what else? Oh, what a coincidence. In our example 1, we get 3 over 2. This is purely coincidental. At the numerator level, what do we have left? Across, we have 3. At the denominator level, we have 2 left, which is one number 1 over 2. What a coincidence. That's the answer we got for example 1. Just coincidental. Let's look at this example 3. Simplify 1 number 4 over 5 divided by 6 number 3 over 10. Let's convert this to improper fraction. 5 times 1 is 5 plus 4, that is 9 over 5. Divided by 10 times 6, that's 60, plus 3, 63 over 10. So we have 9 over 5 times y. We change the division to its inverse. Therefore, the divisor must change also to its inverse. That is 10 over 63. So, we break numbers to their factors. So, look at what I want to do. 9 over 5. Yes, I can break 9 into 3 times 3. But I suspect and I can see that 63 is a multiple of 9. So because of that, see what I want to write. I will now write, for 10, I will write 5 times 2. I break that into factors. All over, I will now write 63 as 9 times 7. 9 times 7 is 63. So, you can see that 5 cuts 5 neatly. 9 cuts 9. At the numerator level, you have 2 left. At the denominator level, you have 7 left. That is our answer, 2 over 7. You can see that if you cut your work like this, it will not look clumsy to whether teacher checking your notes or parents at home checking your notes. Do you understand? Thank you. We come to the next subheading there, which is multiplication of fractions. Example 1. Find the product of 1 whole number 2 over 11 and 1 whole number 7 over 26. Let's convert each of them to improper fraction as we link them with the operation. 11 times 1 is 11 plus 2, that is 13 over 11 times, that's the operation. Product means multiplication. Product means multiplication. So 26 times 1 is 26. 26 plus 7, that is 33. 33 over 26. Multiplication now. To cut this, remember what I said under division? For neat cutting, break these into factors. So you have 13 over 11 times 33 is 11 times 3 over 26 is 2 times 13. So now let's begin to cut. You see that 13 cuts 13 with ease. 11 cancels 11. What is this? 3 over 2. I think in today's class there is something about 3 over 2. So answer is 3 over 2, which is one whole number 1 over 2. Example 2. Simplify 2 whole number 1 over 2 in bracket, whole raised to power 2, of 4 over 5 in bracket, whole raised to power 2. Let's express the number in the bracket here in an improper fraction. 2 times 2 is 4, plus 1, that is 5, over 2, all raised to power 2. This whole F means multiplication. Then 4 over 5 raised to power 2. So this 5 over 2 raised to power 2 means 5 over 2 times 5 over 2. That means 5 over 2 in 2 places. Times 4 over 5 in 2 places is 4 over 5 times 4 over 5. So looking at this, easily you can see that this 5, we cut this 5. This 5, we take care of this 5. So we can write 1 over 2 times 1 over 2 times 4 times 4, that is 16 over 1. 4 times 4 is 16 over 1, because 1 is what we have left here, over 1. So 1 times 16, that is 16, all over 2 times 1, that is 4. 16 divided by 4, answer is 4. Do you understand? So answer is 4. That is the end of that. Let's consider example 3. Simplify 4 over 11 of 3 whole number 2 over 3. This is 4 over 11 times, wherever you see this whole F is multiplication in mathematics, of, you convert 3 whole number 2 over 3 to improper fraction. 3 times 3 is 9. 9 plus 2 is 11 over 3. Look at this. 11, we take care of 11. So we have 4 over 3 left. So 3 in 4 is 1, remaining 1 over 3. So that is the end of that.